Hello, how are you? Welcome to a new class. In this class, we are going to be discussing more in depth about a conceptual issue, and it primarily has to do with the storage and management of objects. When we introduced the architecture back in the first classes of this course, we showed this block diagram, and punctually we see that there are 3 of these containers that are associated with storage. 2 of the same, we already know from OMniLeads. 1x in the center 7 is Reddit for implementing system caching functionality, and Postgres for implementing the storage of relational data and of structured data. But there appears a third storage technology in OMniLeads, and it is object storage. Specifically, when we deploy OMniLeads, all in one, that is all the components deployed by OMniLeads, and coexisting within, until now as we were seeing, on a desktop or on a Linux server with Docker Compose. This technology is driven by Minio. If is like PostgreSQL, Minio is to object storage. Minio is who facilitate the functionality of object storage in OMniLeads. But well, let's take a closer look and see a little bit more about what exactly this is about. Object storage. Object storage, well, emerged somewhat recently and was created in response to the needs of modern applications, which are oriented towards video storage and large volumes of data that grow exponentially over time. Applications that operate in the cloud. Applications that have or support a significant number of integrations. And then object storage as a concept is born in response to that very need, being able to store unstructured data, audio, video, images, files, and binary files in general. Therefore, the design of itself inherently makes each of these data an individual object, unlike block storage and file systems, which is what we have been traditionally using. Object-oriented storage treats each piece of stored data as an object with its own unique characteristics, which are going to be the payload, so to speak. Specifically, assuming an asterisk a recording of a call, the payload itself. On the other hand, we have the object identifier and metadata. We can enrich a lot to object with metadata, which later can be very useful to be used, for example, in the integration with other applications. All this is done through a full network API. By simply doing something, let's say pushing or searching for a file, a put, a get, we are going to be interacting with SAP RESTful. We are going to be able to use, save, query, or retrieve these files. This format of this object-oriented way of saving has a series of advantages that, as I say, respond to a demand that began to arise in modern applications. On the one hand, one of the main advantages is scalability. This type of systems that already bring resolved in a very simple way. What is the replication? Data and the possibility of clustering, the instances of object storage. Already all the protocols and specifications were generated to just give answer to these houses. The ability, many times exponential, of this type of applications. Modern, where we are seeing that the data as such are driving the world, the technological world above all things. And well, storing, retrieving, or being able to respond to those levels of storage which were not found in traditional block storage technologies or NFS-type network storages, for example. So directly performing it against a REDful API. And on top of that, making it a matter of scaling elastically is one of the significant advantages that object storage technology has. The metadata management is also very interesting because we can greatly enrich the objects, then to facilitate the search and the processing of that data using that metadata that is added as a layer to the payload itself of the file that we are saving as an object. Then we have, well, the remote access. As we are saying, it is very easy to go against a full network API, being that the most block storage-oriented technologies have to do with local networks. This here is already directly accessible in Internet whenever we are going to access to a bucket. That is how they call to the unit where we deposit the objects inside a base oriented to objects, inside a bucket of storage of objects. To use this full API network, we simply need the URL where is published, the name of the bucket where we are going to deposit the objects, and whenever we have to make an operation, we have to make an authentication with CLI and password. Isn't it true? Then on the side of the remote access, the truth is that it is very simple. And here I think the strongest point of all, especially if you are interested in what is the contact center as a service, where generally each subscriber of the service is given a certain number of days to consult the recordings, which is, well, in OMniLeads today, what occupies more space. Each of the recordings of the call, the cost of this technology is significantly more economical than block storage technology. In fact, any cloud provider can compare. To put it simply, we can say that it is between 70 to 80% more expensive to use block storage, which means saving recordings directly on a disk in the instance of OMniLeads, a disk that is associated with the instance. The cost per giga is much higher than the cost per gigabyte of utilizing this technology. And well, then there is also one of the advantages. It has to do with versioning because, well, each object can actually be viewed, say, have a historical of how it was versioned, the content of the object as such. So, well, OMniLeads implements this kind of storage. On the one hand, as we say, asterisk saves all recordings and sends them to a bucket. Django, for example, the part of audio management, when we upload audio to Django, we upload music on hold, also saves it in object storage. All the static content that Django serves also in the application also uses object storage. At the time of, well, search for recordings, the search page for recordings, you will see that also the recordings will search and list them from the object storage, and well, that OMniLeads is generating information and storing the storage object allows us, for example, that applications such as speech analytics applications that just use all the information from these recordings and all the information from these recordings to process and draw some data or conclusions. Easily access this full API network and can be integrated with OMniLeads in a very easy way. Not to mention, well, already from what would be the extraction of this data to train machine learning or artificial intelligence models, well, it makes our lives much easier with this kind of technology. That's why it is the de facto technology for unstructured data storage in modern cloud applications. As we said, OMniLeads, for example, This is a figure that we sit. Another example, act number A. Every time asterisk finishes processing a call, the does a put, say, sends it over the full API to the bucket. It's stored in the bucket as a non-hierarchical object with its unique identifier and metadata. And then the record search view, what it's going to do also, go to the network full API to fetch all the files that comply with the filtering that has been performed. These files are presented, and when one hits download on one of these files, what you're actually doing is a download from the bucket by the browser to the workstation from where you are looking for the recordings from where you are downloading. So, well, here's the idea. Back in OMniLeads, when we are discussing an instance that we deploy, using, for instance, Docker Compose on desktop, or as we observed in the previous classes, on a Linux server. The technology pulling the object storage is Minio, as we mentioned, is a manufacturer, let's say, of a technology, open source, that implements the object storage. But really, this is starting to make a lot of sense, especially in contact center as a service schemes. When the object storage is located outside, as we have here in the documentation, we have this part that says, well, to deploy in or a virtual machine. There is a second part. We were deploying this. The second scheme that comes up is using object storage, which is provided as a service from a cloud provider. Because what's going on? Actually, when we deploy this in previous classes, we look for the recordings, they are saved, they can be consulted. Let's say it's all working at the object storage level. But actually, although it is in Minio here, implementing the object storage and providing the full API network and the credentials and everything for the application to work. As we were explaining object storage, the problem is that this is actually saving on a disk here, in a disk that can be attached or the same disk that brings the instance. But we are paying the giga of storage of recordings to cost of block disk. Different is already this approach. That is, use directly, outsource, consume as a service. Object storage technology in that deploy OMniLeads without Minio, because it is not necessary that Minio is operational, because what is object storage will be consuming as a service of a cloud provider. So the recordings, the Django stuff, the backups we make of Postgres, the backups we make of configuration, we're going to be able to dump everything in this bucket, and we are going to pay the actual storage cost that the provider as a service. That there is indeed, as I mentioned, a cost with a 70% or more of saving when using this storage compared to using the local storage of the machine, of the host, the block storage. No, much more to add. I invite you to dig deeper on that. It was very introductory, very much on top of this object storage for whoever wants to go deeper. There is a lot of information of great quality on the net, but well, we are now going to take this into practice and move forward with a installation of OMniLeads with Docker Compose, but using an external bucket of object storage provided by the cloud provider.